Hello everyone, welcome to video lecture series on microcontrollers and applications. In this lecture, we are going to discuss about memory organization of 8051 microcontroller. In lecture 3, we discussed pin diagram of 8051 microcontroller. Just we'll recap once. We'll discuss the pin diagram of 8051 microcontroller, its 40 pin configuration and its ports, where we discussed port 0, port 1, port 2, port 3 and their alternate functions. In addition, we discussed power supply requirements and oscillator pins, how we will provide the clock pulse to 8051 microcontroller, some control signals while uh, interfacing with memory and I/O devices. Coming to learning outcomes of this session or this lecture, you may be able to identify the different memory types used in 8051 microcontroller. That is RAM, ROM, SFRs, and then you may be able to discuss the difference between internal and external memory organization. Why? Because the 8051 microcontroller is having internal memory, on-chip memory. Whenever it is not sufficient, it will go for external memory. So that means you can able to differentiate these two memories after completion of this session. Then you may also able to analyze how a bit and byte addressing is managed in 8051 microcontroller. Then the 8051 microcontroller memory supports Harvard architecture. The Harvard architecture means both memories and addresses and data are treated as separate units. That's where the 8051 microcontroller supports 64 kilobytes of external program memory, 64 kilobytes of external data memory. But already we know that the 8051 microcontroller is having internal on-chip memory. That is of 128 bytes of RAM, which is used for data memory, 4 kilobytes of ROM, which is used for program memory. In addition to this, wherever this internal memory is not sufficient, we can extend the memory up to 64 kilobytes of external RAM and 64 kilobytes of external ROM. Then we need to discuss each and every memory organization. These are the memories supported by 8051 microcontroller. Then we need to discuss how these are organized, how we can access. We need to discuss. Okay. First, we'll go with 128 bytes of internal RAM. That is our data memory. This 128 bytes of internal RAM is divided into three groups. They are bank registers. These are also called as working registers. Next group is bit or byte addressable locations. Next group is general purpose RAM area. Internal data memory organization of 8051 microcontroller. That is nothing but RAM organization. So first it is having working registers. The 8051 internal data memory first is group is working registers. These are working registers or register banks. Then bit or byte addressable locations. These are of 16 locations and remaining 80 locations are provided for general purpose RAM area. These are 80 locations, these are 16, these are 32. 32 locations are provided for banks. Register banks are working registers. So here you can see these working registers are grouped into 4 banks. The working registers are grouped into 4 banks. They are named as bank 0, bank 1, bank 2, bank 3. There are 4 banks. each bank is having registers named as R0 to R7. Here also R0 to R7. Here also R0 to R7. Here also R0 to R7. If you observe these registers, each register is also having their address. Okay, R0 register of bank 0 is having a address of 00H, and R0 register of bank 1 is 08, and similarly bank 2 register R0 10, and similarly this one is 18. So every in the register is having here address. That means we can identify every register by using its address. Its address, or you can also with its name. With its name. Okay. If address is used, it is a unique address for each and every register. But when you are using its name, what happens here? There are 4 registers are available in each bank. So but how they are differentiated? By using bank. This is bank 0 R0, this is bank 1 R0. But when you are using name, you need to program the RS0 and RS1 bits of PSW, RS0 and RS1 bits of PSW in order to select the banks. Suppose for example, these two bits are equal to 00, then which bank is selected? Bank 0 is selected. 01 means bank 1 is selected. 10 means bank 2 is selected. 11 means bank 3 is selected. So these two bits are available in program status word PSW of 8051 microcontroller. By programming these two bits, you can access any bank. But already we know that after reset of 8051 microcontroller, all internal registers are cleared to 0. That means this PSW is also cleared to 0. So whenever PSW cleared to 0, the RS0 and RS1 register bank selection bits, RS0 and RS1 register bank selection bits will become also 0. Whenever these two are 0, that means by default bank 0 is selected. That means default bank is always bank 0 only. Default bank is bank 0. But whenever you require any other bank register, so you can program the PSW bit RS0 and RS1. Okay, so this is about bank 0. So bank 0 is acting as here default bank. Next, coming to bank 1. Bank 1 is also used as a general purpose bank. So that means you can utilize these registers as general purpose registers. In addition, it is also used as a default stack. Okay, it is also used as a default stack. Why it is called as a default stack, we'll discuss now. So let us see now. After reset, we all know that all internal registers are cleared to 0 except stack pointer and ports. The stack pointer is having 07H. That means which is pointing to 07H. Stack pointer is pointing to 07H. So here we need to know the one concept here, that is subroutine. Subroutine and stack. First we'll discuss what is a stack. Stack is a part of internal memory which is used to store addresses and data while subprogram is executing. So let us consider a subprogram is executing. So here this is a mainline program. While executing a mainline program, a set of instructions are repeated more number of times. We'll write as a subprogram normally. When you are moving from mainline program to subprogram, we need to store some data, some addresses in somewhere. So that's why a stock is provided. Okay, a stock is provided for store address and data in internal RAM. That's why stock is the part of internal memory. It is part of internal memory, which is used to store data or addresses while this subprogram is executing. While this subprogram is executing. And here, what is the use of this pointer? The pointer is always used to point the most recently stored word address. Stock pointer is a 8-bit register. In 8051, it is a 8-bit register, which is used to store, which is used to point top of the stack. Top of the stack is nothing but most recently stored word address. That means up to this point, the stack is filled. By default, it is having 07 is nothing but I can mention that here up to this point, the stack is filled. Then to access this stack, 8051 uses only two instructions. One is push, another one is pop. Push is used to store some data onto the stack, some data onto the stack, and pop is used to retrieve the data from the stack, retrieve the data from the stack. So that means only two instructions are used. And here, first always we need to push the data. We need to store the data. So whenever any push instruction is executed, the stack pointer is incremented by 1. That means the first available location for the stack is here 08 location. So that's why the bank 1 is called as default bank. And one more important thing you need to note down here. By default, the 8051 is provided only 8 bytes for stock. Only 8 bytes for this stock. But whenever some applications, you may require more than 8 bytes. In that case, you need to relocate this SP to this 2F location. 2F. So when you relocate this, so here you can get maximum of 80 locations. Maximum of 80 locations. Whenever this is not sufficient, the default stock is not sufficient, you can relocate your SP to 2FH. Then you can utilize 80 locations here. This is about bank 1. So bank 1 is used as a default stock. Then similarly bank 2, bank 3 and bank 2 and bank 3. So these two banks are general purpose registers only. So you can use temporary registers, these registers as temporary registers, and similar to bank 1, but only requirement is to use these two banks we need to program RS0 and RS1 bits. So all registers, and here every register can be accessed by using their names as well as their addresses. This is about working registers. Coming to bit or byte addressable locations, there are here 16 locations are available. These are 16 locations are available, and in these 16 locations, each bit is addressable. Each bit is addressable. That means you can see here the expanded view of this 20 location. This is the expanded view of only 20H location. This 20H location, we are having 8 bits, and similarly 21 is also having 8 bits. So total 16 locations into 8 bits. That means total 128 bits are available. These 128 bits are having their own addresses. So what are the addresses here? 00H, next one is 01H, 02, 03, 04, 05, 06, 07. And similarly 08 to F and 10 to 17 and similarly 78 to 7F. These are the byte addresses for these locations. Okay, these are the byte addresses, but these are the 00H to 7F. These are the bit addresses. Okay, bit addressing is nothing but individual bit can be programmable here. So that means you can access individual bit. So, sir, how can we access? So there are 3 bit manipulation instructions are provided by 8051 microcontroller. These instructions are clear bit, set bit, and complement bit. Okay, CPL for complement, set bit, and clear bit. Suppose, for example, I need to set this bit. Here, I need to make logic 1. So, what is the address of this one? 01. Then I need to execute this instruction. Set bit 01H. Once this instruction is executed, it is automatically set to 1. Here, this location will be set to 1. This bit in this location, it will be set to 1. Suppose I need to clear this bit. Then I need to execute CLR 00H. And here we are always mentioning that bit, set bit, clear bit, here complement bit, CPL bit. So, but we are not mentioning, but we are reading complement bit. So when you are provided this address is nothing but this is a 8-bit address which is related to bit address only, not byte address. Okay. For these 3 instructions, when you are using any 8-bit 8-bit number, so that is related to bit address only. It related to bit address. So in this way, we can access individual bits of these locations. In addition, you can also access entire location at a time with the help of this 20 byte address. When you are using a byte address, you can use instructions like this: move a comma 20h. Means 8 bits are copied to accumulator now. So in this way, similar way, you can access remaining locations are also. This is about bit or byte addressable locations within the internal RAM of 8051 microcontroller. Next, we'll discuss general purpose RAM area. So for general purpose RAM area, there are 80 locations are provided from 30H to 7FH location. 30H to 7F location are provided for general purpose RAM area where you can store your data or you can retrieve your data. Suppose for example, I want to store a data in a 30 location, 30H location, sorry, 50H location. Let us consider this is 50. So to store this, you need to write like this: move 50H comma some data hash 12H. Whenever this instruction is executed, this 12H is copied to this location. So now it will becomes 12H. Similarly, suppose I need to read the data from this some location. Suppose for example 70H location. Then you need to use this instruction: move a comma 70H location. That means the 70H location content is now copied to accumulator. Suppose for example, here 28 is available in this location. Let us consider 28 is available. This 28 is now copied to accumulator. After execution of this instruction, A gets 28, not 70. So this 70 is the address. This 70 is the address of a memory location. This memory location contents, what are the contents here? 28. This 28 now copied to A register. So that means you can access any location, you can place any data, or you can retrieve any data from these general purpose locations, which are ranging from 30H to 7FH location, and that's why these are called as scratch pad locations. That means you can always use these locations directly. Okay, you can store and retrieve your data whenever you require. So that's why these locations are also called as scratch pad locations. So this is about internal memory organization of internal data memory organization of 8051 microcontroller. And if you observe this, the address is normally represented with hexadecimal number. So the address range for internal RAM is 00H to, if you observe here, this is from 00H to 7F location. In decimal form, you can represent as 0, which is represented from 0 to 127. 127 decimal, this is an hexadecimal. Okay, so from this we can conclude that working registers are 32, bit or byte addressable locations are 16, 80 locations are provided for general purpose RAM area. Then special function registers and their addresses. And if you observe the previous slide, we are used 8-bit address. We are used 8-bit address. But in that 8-bit address, the MSB bit is 0. Okay, MSB bit is always 0. So because of that, you are getting only 128 bytes of locations provided for RAM. If I make MSB is equal to 1, you may also get other 128 addresses. Okay, that means here if you make this is equal to 1, so here 128 addresses are available. So out of these 128 addresses, few means here 21 addresses are provided for SFRs in 8051 microcontroller. SFRs are nothing but special function registers. They are having a specific function. Okay, not general purpose function. They are having special function. Suppose for example, this SP is a special function register. So what is the function of this one? It is having a stock pointer. Suppose if you consider port 3, which is having a port 3 latch only. So that means every special function, these 21 registers are having special functions. But if you specify R0 to R7, which are available in banks, these are used as a general purpose register, GPRs. Okay, these are GPRs, but all the registers represented here having a special function. So A is a accumulator, B is for arithmetic operation, DPH is only for external pointer, DPL is also pointer. So every register is having a special function. So that's why they are treated as special function registers in 8051 microcontroller. And one of the important thing here you need to note down. So every register is allocated with some address, but this address is above the internal RAM. Why above the internal RAM? We are used 8-bit address. Okay, we are used 8-bit address. Out of 8-bit address, for RAM we used MSB in that 8-bit address is equal to 0, but for special function register this is equal to 1. So that's why it is always above the internal RAM only. So that's why these addresses are ranging between only 00H, sorry, 80H to FFH. Whatever the addresses here mentioned, only 21 addresses are we are used, but these 21 addresses are in between these two addresses only. So if you observe here, E0, F0, 83, 82, A8, B8, port 0 latch is 80, port 1 is 90, port 2 A0, port 3 B0, power control register 87, program status for D0, serial port control 98, serial port data buffer 99, stock pointer 81, timer mode control, timer or counter mode control 89, timer or counter control 88, timer low byte 8A, timer 0 high byte 8C, and so on. So these are the addresses for special function registers. Okay. Then coming to program memory organization of 8051 microcontroller. So normally the program memory is depends on EA bar pin of the 8051 microcontroller. Program memory is depends on EA bar pin. So let us consider if it is equal to 0. If it is equal to 0, the 8051 microcontroller is utilizing external memory only. External memory. Okay. But when EA bar is connected to, that means logic 1, it uses first internal memory plus external memory. First it will uses internal memory, then it will use external memory. So this is the function of EA bar pin. So we will see the how your memory is organized under this EA bar pin connection. So let us see. First, we are supplied logic 0 by connecting 0 volts to EA bar pin. We are supplied logic 0 to EA bar pin by connecting to ground. Okay. Once it is connected to ground, it will directly use 64 kilobytes of external program memory. External program memory, and which is ranging from 16 zeros to 16 ones. Why? Because the 8051 microcontroller is having 16 address lines. It is having 16 address lines. So 16 address lines we can represent. The starting address is 16 zeros to 16 ones. Okay, this is the starting address, and the ending address is 16 ones. The ending address is 16 ones, but we can represent writing and reading it is difficult. So that's why we'll, instead of using binary system, we are using hexadecimal. So in hexadecimal, we are grouping 4 bits into one hexadecimal digit. So that means 4 zeros H2, 4 FH. So that means the address is ranging from 4 zeros H to 4 FH. This is the range of external program memory when it is connected to ground. EA bar signal is connected to ground. Similarly, we need to discuss program memory organization under EA bar is having logic 1. So how to provide the logic 1? By supplying 5 volts. So then we will supply 5 volts to EA bar pin. So then how it will behave, we need to discuss now. So now the EA bar is connected to 5 volts. Once it is connected to 5 volts, First, it will utilize internal program memory. Already it is having an internal program memory of 4 kilobytes. That means first it will utilize this memory. If it is not sufficient, we can go with the external memory. So, but this external memory is starting from, the address is starting from 1000H. So it will have only 60 KB. Already 4 kilobytes is available here. 4 plus 60, total 64 kilobytes. Okay. So this is the addressing of memory under A bar is connected to 5 volts. This is the organization. Okay. Similarly, external data memory. So when you are considering the external data memory, you need to completely use external data memory only. So the 8051 microcontroller supports external data memory also of 64 kilobytes, which is also ranging from 40H to 4F6. So why? Because it is a 64 kilobytes of memory. So data memory is normally used for to store the data. Program memory is used for to store your application codes as well as some constants. Okay, this is the complete memory organization of 8051 microcontroller. Then summary of this lecture. In this session, we explored the memory organization of the 8051 microcontroller. The covered key components are internal memory and SFRs, external program memory, external data memory. Next class, we will explore the addressing modes of 8051 microcontroller and how they enable flexible data access and instruction execution. Today quote is memory may be invisible, but in a microcontroller, it holds the blueprint of every intelligent action. Thank you.